Welcome to the world of lively underwater havens, commonly referred to as the rainforests of the sea, and mostly found in the shallow sun-drenched waters of tropical and subtropical regions. Coral reefs are known for their vibrant colors and immense support of marine biodiversity. They are vital underwater ecosystems formed by colonies of tiny animals called coral polyps. These polyps secrete calcium carbonate to form the famously intricate rock-like structures of coral reefs. Even though they cover less than 1% of the ocean floor, these coral structures host at least a quarter of all known marine species. But let's say you're not all that interested in the ocean, marine animals, or even science in general. Why should you still care about the health of coral reefs? Beyond maintaining biodiversity, coral reefs help protect our coastlines from erosion and lower the risks of coastal threats like tsunamis. They also are economically significant in the tourism industry, attracting snorkelers, scuba divers, and beachgoers to see the beautiful aquatic scenery. As the largest reef system in the world, tourism at the Great Barrier Reef alone generates an estimated $1.5 billion a year. Reefs' ability to support large amounts of fish also means that fishing industries are able to provide food and support the livelihoods of millions of people across the globe. Even in the realm of pharmaceutical and biomedical research, the use of the coral's unique chemical extracts and bones have been used in treatments for cancer, arthritis, and cardiovascular diseases. However, this intricate balance of reef life faces challenges that are caused by human activities. One main issue affecting corals is ocean acidification. This is caused by the excessive burning of fossil fuels that release an increased amount of carbon dioxide into the atmosphere. This CO2 is then absorbed by the Earth's oceans, where it reacts with water to form carbonic acid. Greater concentrations of hydrogen ions reduce the pH of the seawater. As the seawater becomes more acidic, carbonate ions are used up by the free hydrogen ions and become less available for coral polyps to build the tough calcium carbonate structures of reefs. More fragile structures means that corals will have less resilience against any physical damages they may incur. In addition to ocean acidification, other human-induced disturbances like global warming and pollution contribute to a phenomenon known as coral bleaching. Corals have a symbiotic relationship with an algae called zooxanthellae, which adorn the corals with their bright colors and provide them with energy through photosynthesis. However, increased greenhouse gas emissions cause elevated sea temperatures and ocean acidification levels beyond what corals can tolerate. These conditions prompt the corals to produce toxic reactive oxygen species as a stress response and expel the symbiotic algae that are critical for their survival. The remaining bleached appearance of corals indicates the disruption in this coral algae symbiosis, making them more susceptible to diseases or potentially death. Ocean acidification further exacerbates the effect of bleaching. The increased acidity that weakens corals makes them more susceptible to bleaching events, which raises more concerns about mass mortality among coral populations. The potential for these events to occur more frequently is a significant ecological concern. Recent studies have addressed that even though human-induced pressures on these reefs are still of environmental concern, there is a low inherent risk of extinction for coral populations supported by the fossil record. Thankfully, this suggests that the current reef crisis may not lead to a mass extinction in the near future. However, in hopes of regulating future threats to coral population levels, cutting-edge research efforts are focusing on the possibilities of how corals may be able to physiologically or genetically adapt with environmental changes. Frontiers of interest involve corals that have better heat tolerance because of their ability to host more resilient zooxanthellae, and the discovery of supercoral species that are inherently more tolerant of high temperatures. Reef scientists are working to identify, breed, and reintroduce more of these corals in the ocean. The question now is, how quickly can future scientists reintegrate these resistant corals and help restore coral populations across the globe? As we reflect on the profound interconnectedness between marine ecosystems and our society, coral reefs play a crucial role in maintaining this delicate balance. With the goal of preserving and protecting coral reefs, the words of the United Nations Ambassador Peter Thompson ring true: "We cannot have a healthy planet without a healthy ocean."